Here we'll just talk about the surface area that goes around the outside of a cylinder without the top and the bottom. So someone needs to design a wrapper for a can of tennis balls. Each can is just large enough to fit 3 tennis balls, and each ball has a diameter of 6.7 centimeters. We need to calculate the surface area of the can that's covered in the wrapper. So that's just the wrapper around the outside, not the top or the bottom of the can. If you go to your formula sheet, this is a great chance to look at how the formula sheet can help us in these situations. We find that the surface area of the can is actually broken apart for us, and also we get the full equation of the surface area of the can. But you notice that it tells us the area of just the side of a cylinder is 2 pi RH. So if we know those things, the radius of the cylinder and the height of the cylinder, we should be able to calculate just the side that goes around the cylinder. So going back to the question, do we know the radius and the height? And not directly. We can see that we're told the diameter of each ball is 6.7, which means that across the top of the cylinder, we have a diameter of 6.7 centimeters. We can turn that into a radius easy enough, but that means we're also not told the height directly. But we are told that these cans hold 3 balls stacked as tight as possible, which means you have one on top of another. So that's a 6.7 centimeter across ball there, one in the middle, and then one at the bottom. And so that means that the height must be equal to 3 times 6.7 centimeters. So within the question, we're able to determine that radius and the height. So let's calculate that for each. First I'll do the height. 3 times 6.7 is 20.1 centimeters. And then if 6.7 is the diameter, we can calculate the radius by dividing that by 2. So that's 3.35 centimeters. And now we have each part that we need to calculate the area of the surface that goes around the cylinder, that rectangular side that wraps around. So that's 2 pi, r is 3.35, times h is 20.1, and then we can plug this all into our calculator to get the area. And we get 423, and because we're not told otherwise, I'll just round to one decimal place, 423.1, and my units are going to be, this is an area, so square centimeters. So that's the area of the wrapper.